Let us learn another problem from atomic physics. In an experiment for positive ray analysis with Thomson method, two identical parabola are obtained when applied electric fields are 3000 and 2000 volt per meter. The ratio of mass of particles which are singly ionized and doubly ionized assuming same magnetic fields are. So four options are given. We have to find the right one here. Solution. Here there is a plate. Here the vertical axis let us consider as x-axis and the horizontal axis let us consider its y-axis. When there is no electric field and no magnetic field, this positive ray goes straight and hits the center O. Good. Now we are giving some potential to these plates. The upper plate takes negative voltage and the lower plate takes positive voltage. As these are positive rays, what would happen? They enter this electric field, right? The electric field will be from positive to negative plate. We call it as E. Now this positive ray enters, get deflected towards negative plate, hits the vertical x-axis. We considered it as x-axis. At a point, we call it as x. Good. Path. For upward displacement due to only electric field which is in the upward direction. Ux equals 0. What is Ux? The initial upward velocity is 0. So as we use the formula is equal to ut up plus half at square, ut becomes 0. We left with only displacement equal to half at square. So x equals half times ae t square. A is the acceleration due to electric field and t is the time taken by this positive ray to cross the electric field. So x equals 1 by 2 and we replace the acceleration by the electric force by mass. Electric force is replaced by EQ and the time is replaced by the length of the plate divided by the velocity of the positive ray. Good. And the x proportional to E times Q by M times 1 by V square. Right. Let us write this near the diagram. X proportional to E times Q by M times 1 by V square. Right. Now let us remove this electric field. Let us apply a magnetic field. This magnetic field must be in the direction of electric field. Then only we will get a parabola. Otherwise, we don't get a parabola. Right. So magnetic field we call it as B, and it goes from down to up. Now this positive ray enters and get deflected. Right, perpendicular to the magnetic field and reach the y-axis at a point y. Let us write. For for outward displacement due to only magnetic field which is in the upward direction. So uy equals 0. The initial outward velocity is 0 and the displacement y is given by half abt square. Here the acceleration due to magnetic force. So let us replace acceleration due to magnetic force equals magnetic force divided by mass and the time of course replaced by L by V. So y equals 1 by 2 bqv by m multiplies L by V the whole square. So y equals 1 by 2 multiplies bqv by m multiplies L square divided by V square. So let us take the proportionality equation y proportional to b times q by m times 1 by V. Let us write this near the diagram. Y proportional to b times q by m times 1 by V. Let us now apply both the field. Now, for displacement due to both electric and magnetic field, both are in the same direction. Then the positive ray neither go to point X or to point Y, but it will go to a point XY in the XY plane. Now we know what is X here. X proportional to E times Q by M into 1 by V square. What is Y proportional to B times Q by M into 1 by V. So let us go with Y square by X proportional to B square multiplies q by m square multiplies 1 by v square divided by E multiplies q by m multiplies 1 by v square. So y square by x proportional to 1 by v square on upper and lower side get cancelled, 1 q by m getting cancelled, so we get b square by e multiplies q by m. In our problem, it is clearly given that both the particles assume same magnetic field, so b2 constant here, so y square by x proportional to 1 by e times q by m. In this type of problem, this is the starting formula, right? If you get a problem like this, you have to start your problem with this formula, y square by x proportional to 1 by e times q by m, right? This is the starting point. So let us solve the problem for singly ionized positive ray. So it is y square by x proportional to 1 by e1 multiplies e by m1, because singly ionized the charge is one time e. Right. For W ionized, this particle also takes the same parabola. So we can say that the left hand side y square by x as it is proportional to the second particle 1 by E2 multiplies W ionized, so 2E by M2. So we equate these two equations, 1 by E2 times 2E by M2 equals 1 by E1 times E by M1. So we go with M1 by M2, we get E2 by 2E1. As we substitute the value of E2 and E1, E2 has 2000 and E1 has 3000, we get the final answer M1 by M2 equals 1 upon 3. The right answer is 1 is 3. Thank you, children.